Good morning and welcome. We're going to be talking about Agentic B, how to get AI agents to talk to Tetragon. And my name is Himal. I'm the co-founder and CTO at Canopus, based in Sydney, Australia, the land of kangaroos, great beaches, and amazing coffee. Let's get started. So recent developments in the AI are reshaping the design patterns in observability. Starting from high-fidelity data is becoming more critical than ever because the accuracy of the AI agents depend on the quality of the data. And that's where Tetragon really shines by providing us high fidelity for golden signals of security observability as close as possible to the event itself. The second, AI agents can't really work with raw data, so we need to create contextualized intelligence so they are able to perform actions and are able to understand the data the way humans do. Finally, the manual human-driven dashboards will be moving and shifting towards agentic workflows, and that's going to move the whole observability space from reactive to proactive. Let's try to build out an architecture. So we're going to be using Tetragon to extract information on processes, file system access, network, and use enforcement policies. And we will augment Tetragon with FlowPulse sensors to maintain its state on the network traffic. So we are now generating a lot of events for every single packet, performing aggregations, and talk to Tetragon over the gRPC API to push enforcement and dynamic tracing policies. So this forms our high-fidelity data layer. Followed by that, we're going to convert raw observability data into asset evidences, asset being containers or VMs, or we can call it workload, in the form of classification of the container. Is it a web server? Is it a database? Or is it external talking? By then baselining the behavior of the containers, looking at the data flow over the network, what sort of data is being exchanged and to where, and then classifying the runtime profile of the container into anomalous and malicious behavior. And this feeds into building out the workflows by the AI agents. Here we're using the GPT-4o model as well as the Claude Sonnet 3.0 to build out our workflows. So let's take a look at two examples of the workflow and how we can build that out. First one is the runtime vulnerability prioritization. So static vulnerabilities don't really work very well because too many false positives, and not all of them are actually exploitable in the application. And there are too many of those, could be hundreds. So to solve this problem, the way we approach it is we first try to get the software bomb using something like SIFT, which will provide you with all the file path that might be in play in all the software packages and binaries. And then we're going to run that through Gripe to get a list of vulnerabilities attached to those paths. And we can also check that against CAF databases. After getting that, we're going to feed back into Tetragon some dynamic tracing policies to track those file paths being executed or dynamically loaded by the processes. And combining this with the network data flow is going to generate our behavioral evidence chains in the form of JSON logs or generated text by the LLM models. The workflow looks like this. The Agentic crew first generates the priority funnel, which brings the vulnerability through critical, how many are fixable, how many are running in privileged containers, to how many are exploitable in runtime. That reduces the vulnerability count significantly. Then the agents would assess the risk using data flows and classification. Is that a container that talks to a sensitive database, or is an external facing, which can increase the risk? And then correlate previous reports that have been generated to look at if there are any updates or changes that have happened in the application. And finally, generates a report for every container vulnerability that needs to be actioned. It takes around 1 to 2 minutes for the agent crew to generate that report and consumes around 30,000 to 60,000 tokens, costing around 25 cents per report, which is pretty good. We'll have a look at a quick demo in a moment, but let's have a look at a much more complicated workflow of runtime threat detection. To achieve this, we're going to be forming an extensive baseline of all the processes in all the information coming from Tetragon in the form of image baselining, process baselining, network baselining, asset classifications, and the data flows. By looking at the runtime behavioral profile of all the containers, we're going to generate evidences in the form of baseline deviations, or runtime context in the form of unseen images, container deletes, sensitive file accesses, host mounts, or access to Linux capabilities in a privileged container. All this forms, again, a part of our behavioral evidence chain tied to every container or an asset in the form of JSON logs, images, and text. So here we are using image to describe the time series behavior on the network, and also the graph of what are the assets the container is connected to. So LLM models are really good at reading the images in a similar way humans do to detect anomalies, spikes, and drops, and to be able to visualize what's really happening without using complicated anomalous detection algorithms. Here, the agentic workflow is a little bit more sophisticated, comprising of 3 different crews. The first one, analyzing and classifying for every container, the evidence chain into malicious or anomalous. Anomalous could be coming as a config errors, or malicious as a result of a threat actor. The second crew then correlate these findings of individual containers to other containers across the whole workloads and cluster. And finally, the third crew attempts to classify these malicious evidences into the Kubernetes threat matrix. Again, all that feeds back into the chain, and this loop keeps on running until the crew decides that the whole event is benign or generates an incident if it is malicious in any way. Let's quickly take a look at how this would work in action. So we are in our agentic UI. Everything here is generated by agents, including the visualizations, and nothing is static like dashboards. So we're looking at the vulnerability prioritization first. As we can see, the funnel has reduced from 700 vulnerabilities down to 3, which are active in runtime. And we can take a look at one of the container reports that have been generated for the first workload in a second. And we see in the report generated the asset information, the summary, and what vulnerabilities need to be actioned, along with the risk assessment that there is a privilege assessment saying the container shares the IPC namespace with the host. It is talking to critical data asset, communications are happening, so the overall risk is pretty high. And we can also talk to the agent's crew, asking, are there any other containers that are have the same vulnerabilities, even if they are not active in the runtime. So it's going to list them all down, because if I'm fixing the runtime one, might as well fix all of them. Now let's have a look at the threat hunting workflow. So right now, no incidents are there, and a threat actor tries to escalate privileges, does a container escape, breaks out, steals some secrets, and then finally tries to exfiltrate data through a reverse shell. This would get detected in 3 different alerts, one of them being the whole incident, the data exfiltration has been detected on the container holding Postgres. And we can ask, OK, what actually happened? What services, parts of containers are affected? It'll list down the summary of the attack pattern. Or we can add what TDPs were used from the Kubernetes threat matrix. And it lists down the execution, data collection, privilege escalation steps that have been taken by the threat actor. We can also ask what was the data that was exfiltrated, or what SQL command was run in the container shell to access the data in Postgres. And it'll be able to tell that, thanks to Tetragon again. And finally, so what can we do about it? Maybe we should not allow running pSQL commands in the container shell itself, so we can human in the loop block the pSQL commands and ask to Tetragon to block this and kill the process next time it tries to happen. All these evidences can also be exported to Open Telemetry Collector and be visualized in Splunk as well. This is the Microsoft Kubernetes threat matrix built out. And all the evidences that have been generated can also be searched through using SPL Or we could build out the visualization dashboards into Splunk as well on the vulnerability funnel. And at the same time, we can also export all this into Datadog as well, whichever platform would support the open telemetry. That's all for the demo. It's just the beginning of what is possible. And thank you so much. And reach out to me to know more. We're going to be also publishing a technical blog tomorrow to go into the depths of how this all works, if we have some time for questions.